now things are going to change. Is that good? It's up to a constant. So as long as I keep everything in centimeters. So it's, yeah, okay, so what's the spring constant? So yeah, I see what you're worried about, but it doesn't matter here. So the force is in newtons, is x is in centimeters. So what are the units of the spring constant? Newtons per centimeter. So as long as everything keeps measured in centimeters. Yeah, and what you're worried about is newtons is kind of a composite unit. It's kilograms. Yeah, kilogram meters per second. Luckily, we don't need it's So now, it's you are standing right here. And the spring, when it's handed off to you, is 35 centimeters. And after you finish, is you stretch the spring to 38 centimeters. So you had to do some work to get from 35 centimeters to 38 centimeters. And I want to know how much work did you do? First of all, we're going to do this all relative to our coordinate system. So x equals 0. This is and then the idea for each x value is we're going to divide this 3 centimeters, 35 to 38 centimeters, into little tiny slices dx. And the reason we do that is each x value has a different force. So as we're pulling over here, it's getting harder to pull. So we did a little bit of work at the beginning, and then more and more work as it gets stretched out. So if you look at one slice, and the way I like to think about it is imagine, well, each x value is going to give us a little window on us watching the spring get pulled through that window. So first of all is how do you calculate work? Okay, the force is determined by what the x value is. So if I am 10 centimeters away from x equals 0, the force is 4. If I'm x centimeters away from x equals 0, what's the force? As we worked out, is the force equation is 4 times whatever the x value is. So the force is 4x. And when we were watching through this little window, what was the distance traveled by the spring? dx. So the work on a slice is 4x dx. Bless you. And the total work is me adding all those together. And then we just need the limits. So when I'm stretched out, when I was handed the spring, it was already stretched to 35 centimeters. That corresponds to what x value? 25. So remember, oh no, 15, right? So remember we said that 20 centimeters was what it was naturally. So the best way to look at that is 15 centimeters beyond natural. And again, so it's 20 centimeters to get to x equals 0. The total distance is 38. So 38 centimeters corresponds to what x value? What is it, 13? 18? That's good to me. So if you evaluated this integral, you would know how much work it took. And what would the units on that work be? Yeah, so how is force being measured here? What units do we have for force in this one? Newtons. Are we measuring distance? So this would be in newtons and meters.
Do you want us to read it?
In theory, you should call it that. That's what you exercise. Since we're recording, happy to let you go on your break and the rest of it. I hope you enjoyed it. I'll see you in 10 minutes if you work through the rest of it.
Work is only, watts is only used to measure electrical work, right?
No.
Watts?
Yeah, it's,